manufacturing. On the one hand, we've made remarkable growth in AM. In 2012, the size of the market was about $2 billion, and we're pretty soon going to approach $20 billion. So although that seems like remarkable growth, I think we can all agree that we haven't had as much adoption in the end parts, the production of end parts, as we would have expected. You probably all know that we started using additive manufacturing in the prototype stages, but it hasn't taken off as well on end parts. We've heard a couple of speeches today that highlighted one of the reasons for this, and that's the knowledge worker gap. Having the understanding of how to leverage this technology and how to utilize it. It doesn't do much good if you have a full-featured machine if not enough people know how to use it or leverage its capabilities. If this isn't actually the only thing, though, that's holding back the adoption of additive manufacturing. The other thing is that we suffer from quality issues and speed issues, meaning it's difficult to ensure that part number 1 is exactly the same quality as part number 1021. And certainly we all know that the speed of some of the 3D printers nowadays is just too small for long, repetitive manufacturing runs. But why? Why is this a problem? Well, one of the major underlying issues with the quality and the speed is vibration in these machines. For those of you who've never used the 3D printer before, when you try to go quickly, when you try to operate it quickly, the machine vibrates. When that happens, defects get introduced into the part, which means you probably have to throw it away. So wasted time, wasted materials. So what do people do nowadays to deal with this? There are three different workarounds that folks use. Number one, they just print slower. They find the fastest print speed that they can print at without sacrificing the quality. The second workaround is adding physical parts to stiffen or dampen the vibration of the printer. Again, though, that's not great because you're adding weight, which means more energy consumption. The third part is even the worst one. It's just buy more printers. If you have a certain requirement to have throughput through your manufacturing facility, you just might have to buy more printers. Wouldn't it be great if we could address the vibration issue with additive manufacturing machines just using software? Wouldn't it be amazing? Well, it has happened. At the University of Michigan, in the Mechanical Engineering Department, a group of researchers has identified an innovation called vibration compensation software. How does it work? I'm going to simplify it by saying there's two parts. The first part is to figure out for a particular printer model, what is the vibration profile of that printer model? Meaning, when is it most likely to vibrate and in what conditions? How and why would it vibrate? In this software innovation approach developed at the University of Michigan, the first step then is to calibrate the printer to try to figure out and predict how it's going to vibrate. The second part of the innovation is to then take that as an input and install vibration compensation software on the controller of the 3D printer. When that happens, essentially this software anticipates the vibration and compensates for it so that you have the desired effect on the movement of the print nozzle. The spectacular results that have been measured with this innovation will astound you. When this software is installed on the controller of the 3D printer, it prints 2 times as fast and with 10 times the acceleration. Yes, you heard that right. 2 times the speed and 10 times the acceleration. We've shown these results in the lab, but we've already also had independent verification of this from 3D printer OEMs. My name is Brenda Jones. I'm the CEO of Ulendo. Ulendo is the company that has worked with the University of Michigan to commercialize this technology, to put it into the hands of folks in the manufacturing industry. We hope you'll come and visit us at our booth, although we won't be there for very long, booth 420. And we will be next week, as many of you probably will, be at Rapid. The founder of Ulendo and myself will be doing a presentation on this technology plus some other technologies that are related at the University of Michigan. The word Ulendo means journey. We hope you'll join us in our journey to increase the adoption of additive manufacturing. Thank you.